everyone, Jess here, and today I'm joined with Victor Oribamise from Kquika's CEO. Thank you so much for joining me today.
Thank you, Jessica, for this opportunity to talk about Kquika and what we are building and our dream for the future of the industry.
Absolutely, it's my pleasure to have you today. So, this year at the Aerospace Tech Review Awards, Kquika's Trakt System won winner of the AI Visionary Product of the Year. So I thought today you could walk us through the system in a bit more depth. But first of all, could you start by just telling me a little bit more about Kquika?
Oh, we started Kquika in 2021. We pronounce Kquika as Kquika, something that is very fast, and the full meaning is quick and unique knowledge access, for our clients. So we want to make knowledge accessible as fast as possible, more than, our nearest competitor in the market. So we are an AI-powered aviation technology company that I founded in 2021 with my co-founder, Oribamise, and we are based out of New York City. Our mission is very simple, but very, very transformative. We want to make air travel enjoyable, stress-free, without any cause of delays, maintenance problem for airlines, and ultimately their passengers. So very, very simple, but transformative. So our story is a bit unique because we got here, not by being from the industry. So I don't have any attachment to the industry. I was in grad school. I have a master's in genetics, and then I went for a PhD in med school. But during my genetics program, I built a software that could predict heritability, so we call it SAFE. So we were able to gather a lot of data from different familiar sources, paternal, maternal, and all of that. So I built a software around that, that could technically predict, what could actually happen. So during the course of the COVID-19 pandemic, while we were stuck at home, I started having these thoughts, I started looking at the industry, I started reading more about the industry, and I discovered that we have a lot of aging mechanic forces, and I discovered that a lot of younger people are not taking up this job. And I discovered that the industry is not actually using a lot of new technology. They are still kind of like in the old ages. So I was like, there should be a way for us to, bring the industry into the new age. So I started talking to a lot of people, in the industry, people that wanted to talk to me, and I'm grateful to all of them. And they started giving me a lot of their learnings. And I was like, I've been able to predict heritability in general, human, animal, and all of that. I was like, we should be able to apply that technology, to predict mechanical failures in planes. So that was how we got here. Then I read for a year. I read from 2020 to 2021. Talked to a lot of people, and then later on we started Kquika. And I think what set us apart is it's kind of like very interesting. So we are not just another startup in the aviation industry. I believe we are a network intelligence company. So we are leveraging the power of collective learning. One of the things we've been able to build into the Trakt System is what we call federated learning, or Chinese wall for the layman. So we are trying to enable airlines share intelligence, without technically sharing data. Because one of the problems I discovered in the industry was the problem of data lock, across the whole sector of the industry. So you just think of it as, like something like a global brain for the whole aviation maintenance industry, where everyone benefits, from collective insights. You give, I give, then, but they are still able to keep a lot of their proprietary data completely private. So everyone is benefiting for that. So why does this matter? So the aviation industry spends a lot of money, every year on maintenance, and about 30% of that goes into unscheduled maintenance that I believe, and everyone knows, could be prevented. So, but because airlines operate in all of these data silos because of competitive sensitivities, so that is kind of like why Chinese wall federated learning is very, very important. And I think the network effect is actually, working, basically because I believe the more airlines join our platform, our predictive accuracy will improve for everyone because the more data you feed into our model, the more they're able to get better. Right now, we've been able to achieve high predictive accuracy, but we are trying to improve it more. The more aircraft we feed into our model, the more they're able to learn from that. So, and I believe in the next couple of years, 5 or 10 years from now, or 8 years from now, we believe all the up to 30,000 aircraft that we have should be on our platform.
Wow, that's very impressive, and such a young company born in those conversations that were happening around COVID. It's really exciting to see the rapid progress you've had and also your trajectory for the future. So you started touching on it a little bit, but if we go into more depth, can you tell me more about the Trakt system? How does it work? What's the purpose? And I believe it's got a sort of 92 to 95% accuracy in predicting these component failures, which is very high compared to industry standards. So perhaps if you can talk me through that side of things as
Yeah,
well.
yeah, absolutely. I mean, we can walk you through, how it works. I can walk you through it. So, uh, it's the trust system actually represents like a fundamental shift in how aviation maintenance, predictive maintenance is carried out. So, we are trying to, beat out industry standard by introducing new technology. So, at its core, we introduce a couple of multimodal assembled approach, which I call our orchestra of intelligence. So each of these models, they specialize in different aspects, of predicting, failures for the aircraft. We have the failure prediction model, which is a deep learning neural network that predicts component failure. We have the component lifetime model, which is a variable distribution analysis for predicting remaining useful life. We have the maintenance optimization model, a reinforcement learning for cost-effective timing. We have the fleet optimization model, which is a graph neural network for system-level understanding. We have the supply chain model, which is a predictive demand forecasting. We have the anomaly detection model, which is a real-time pattern recognition, that's able to understand, what's actually happening, what are the anomalies happening, and so on and so forth. And then we have the federated learning coordinator, which is gathering all of this intelligence into one, aspect, and then trying to kind of like feed it to the client. And before our AI models work on any of this data, we have a couple of four degradation models that we've built into it. So system actually is truly for our sophisticated because of these four distinct degradation models that we will continue to improve upon. So they automatically select the most appropriate approach. For example, with the critical model, which is for components with H score of less than 15%. So another thing is when we get data set from our client, we are able to calculate H score, and this degradation model are able to select, depending on the H score. So if a component is has about H score of less than 15%, so that is a rapid linear decline with about 2% daily degradation. So the critical model is selected. For the accelerating models for rapidly degrading components, which is they have about 8 gradient of greater 0.7. So that is kind of like exponential decay with accelerating factor. And then we have the linear model, which is for something that is just steadily degrading, so just steadily degrading for all of the components steadily degrading. And then we have the variable model, which is a default model, for slow initial degradation, that is for 8 gradient of less than or equal to 0.3. So this is kind of like where failure starts degrading slightly, slowly, and so on and so forth. So, because I came from a science background, and from genetics background, so I looked at it, from a different perspective. So that's kind of like that's how we've been able to achieve AI prediction score more than what is obtainable. So we are not looking at it on a one-to-many approach. We are looking at it from a one-to-one approach. So we've assigned different models, that is able to kind of like analyze, when failure will occur, when anomaly will occur, supply chain, and so on and so forth. So we are not putting all the data sets together. So we have different models that are working, side by side to be able to understand, what's happening, and then we feed it to our federated learning.
Fantastic. That's so interesting. And then how can these insights help airlines to turn the process from reactive maintenance into proactive fleet optimization? And what real world results can this mean for them?
So, I believe this transformation is kind of like at the heart of what we do, and it represents the shift from fix when broken to predict and prevent. So, like the current scenario that we have, traditional aviation maintenance, they operate on three modes, fundamentally reactive right now. They operate on reactive, that is fix after failure, which is very expensive and dangerous. We have the preventive, which is replaced based on calendar hours, regardless of condition, which I think is wasteful. And then we have the condition based, which is basic monitoring, but it has a lot of limited predictive capabilities. So, and I think this leads to a lot of massive inefficiency. It leads to a lot of delays. It leads to a lot of unscheduled maintenance. Then airlines again kind of, they have a lot of terabyte of data daily, but they don't actually have true predictive insights, into all of this work. So, and I think if I'm not mistaken, I think about 30% of components of aircraft components are replaced, but they still have at least more than 40% remaining useful life. So the Trakt approach is based on three revolutionary approaches. So, which is one, we have the continuous monitoring and anomaly detection. So that is a 247 analysis of all of the real-time data stream across the entire fleet, and which leads to a lot of correlation analysis across different components that will be able to spot interdependent issues. So which is moving from reactive to predictive, and then we have the pattern recognition, that identify issues weeks or months, before they become critical. And the second revolutionary approach is the predictive intelligence and early warning, which is failure prediction, with about 30 to at least 60 days daily time. And then, which is also, there's a lot of novel failure mode detection through our federated learning network. And then we have the cascade effect identification, where one component degradation, impacts the others, depend. And I think this actually draws back to our degradation models that we've built into our platform. And then the third revolutionary approach, I believe, is what I call the actionable fleet-wide optimization, which is kind of like maintenance schedule optimization, that is able to balance cost, safety, and aircraft availability. And then it can integrate with crew planning, flight operation, and revenue management systems. And then it can actually it has a lot of risk-based prioritization across the entire fleet. So, so for example, instead of changing, an engine component every 500 hours, regardless of condition, our system can, predict, component A on aircraft Y, that will lead to 150 hours of safe operational hours. Then component B on the aircraft X, you know, same component type, different condition. So we are able to kind of like use our detection models to be able to kind of like identify, what's actually happening on different aircraft, but with the same component type. So this will actually, enable maintenance cycles, that you can schedule, during planned downtime rather than during emergency situation. You can optimize your fleet. There's a lot of intelligence in improvement in intelligence in inventory management, and then you can effectively allocate resources. So that is kind of like where we are currently. That is how we've been able to turn it from reactive to predictive.
Definitely, and that's some really exciting um opportunities to open up for airlines in terms of that sort of streamlining and operational efficiency, as well as crucially safety, which is, of course, the paramount concern for the industry. So we've touched a lot on where the company already is and how it became. What about what's next? What do you see as the next step for Kquika and for yourself personally?
I mean, for the company, I don't think I don't think there's anything that's personal for me or the company. The company is me. I'm the company. So personally, whatever is next for the company is whatever is next for me. Uh, but if I'm to separate, if I'm to have some distinction, I believe for the company we want to build on our network vision. So which is where we are trying to ensure that we're able to scale our network effect, across the whole industry. So, as I mentioned earlier, we want to have all the aircraft, flying across the world on our platform. Uh, in the next couple of months, we are looking at we are raising a 3 million seed round. So, we are looking at completing that seed round. Also, we're looking at scaling our clients. We've been in advanced discussion with a lot of companies in Europe, in North Africa, in Africa generally, and then some in North America too. So we've been able to work with some people already, but we want to work with more people. So we want to have everyone, MRO people, airlines, everyone, on a platform in the next 18 months, in the next couple 18 months. Also, we want to be able to, I believe, what I call the integration economy. We want to launch something like that. It's a strategy that we think we can launch with major MRO and airline software provider. So that we want them to be able to learn, how our technology works, and they'll be able to help us improve, the efficacy and efficiency of our technology. I don't think there should be kind of like, a cut and pieces, technology in the industry, and I think Trakt should be the global brain of maintenance in the whole industry. So that is kind of like our dream, for the company. And 2 to 3 years from now, we by 2027, hopefully we're able to have 10 million in ARR revenue by 2027. Hopefully we're able to reach at least 100 clients, and we could be able to monitor at least 15,000 aircraft by then, with almost 97 to 98% accuracy. And also, as I mentioned earlier on, establish Trakt, as the standard, the industry standard for predictive maintenance across the whole world. And also, expand our federated learning network internationally, in Europe, Asia, all across the world. And our ambitious 5 years goes from now, or at least 5 years goes from now, have about 25,000 aircraft on our platform. So that's kind of like almost all the aircraft flying across the world. So at that particular scale, that means we've become the numero uno of predictive maintenance, in the aviation industry. And I think we will be unstoppable is because the network effect approach is kind of like very great. We are not trying to compete with people. For me personally, I believe competition is for losers, and we are not trying to lose. So our idea is basically collaborate with everybody, so they learn from us, we learn from them, we become invaluable, and that's kind of like the whole idea. So that's kind of like the whole idea. And I think personally for me, I want to continue to build Kquika into one of the greatest company that's ever be founded by anybody in human history. I want to continue to attract, class talent, people that are willing to work, people that are very smart and they are very hardworking. I want to continue to, because as I mentioned earlier, we are a network intelligence company. So I want to continue to attract people that have the same ideology and philosophy about, uh, ensuring that we have safety, ensuring that things are much, much less easier, stress-free for people in the aviation industry and hopefully across the whole global sector of the whole economy. So, and I think the bigger picture right now, and I think we are at this very we are at the beginning of something interesting in the aviation industry, and I think how big industries, our industries, approach operational intelligence is shifting, and I think we Kquika is at the cruise. I think we are the ones that will lead the aviation industry into the future. So that's kind of like what I think. Uh, Personally for me, that and personally for the company, that is kind of like where I think we will be at. So, and as have we mentioned, I've been talking about network effect, and we are not just building like a very profitable company. So we are trying to create a collective intelligence system, that makes aviation safer and more efficient for everyone. So, because we believe every successful prediction we make, it prevents a potential incident. It might not be big, but no matter how small it is, it's preventing something. So, and every optimized maintenance schedule reduces a lot of environmental waste, and every efficiency gain makes air travel more accessible. So, the ultimate vision is seeing Trakt, as fundamental to aviation operation, as radar is to air traffic control. So invisible infrastructure, that everyone depends on. I mean, they must not see it, but everyone depends on the Trakt system. So it makes the whole entire industry work better together, while respecting the competitiveness of the whole player in the industry. So we want to prove, and we are proving that you can create massive value by enabling collaboration without compromising competition. And I think that is a model that can transform industry far beyond the aviation industry. So
Absolutely, and those are some really ambitious goals with some very impressive tech to back it up. And I particularly like what you're saying about collaboration being the true spur or driver of innovation rather than competition. So a sort of collaborative approach to learning. So thank you so much for joining me today. It's been great to get your insights and learn a little bit more about this game-changing system.
thank you very much. It was nice talking to you, Jessica, and thank you for the opportunity. And hopefully, I will see you again soon, and we'll be able to have a bigger stage instead of maybe like not just video calls alone. So maybe we'll be at a very bigger stage. We'll be talking more about what we've been able to build and what we'll be able to accomplish pretty soon.
Fantastic. Well, thank you again.